Now let us consider the second problem. Again, I am considering the same system, particle in an infinite potential well. This time, I am using the same geometry, that is the width is L and the walls are at x equal to 0 and x equal to L. Now this time, the perturbation is some constant times, alpha is some constant, a Dirac delta function which is centered, which is peaking at x equal to L by 2. Okay, what is the importance of x equal to L by 2? It is the center of the that box. Okay, so if you plot it, it will be like this. This is x equal to 0, x equal to L. So this is your potential well. Okay, this is v equal to infinity here at x equal to 0 and L, and this is L by 2, right? So your this perturbation, if you plot it here, will be like this. Okay, a spike at x equal to L by 2, some constant alpha times this one. Okay, alpha is some constant. So we want to find out the first order correctioning. So first aim is calculate the first order correctioning energy for the nth state. Okay, and secondly, we want to calculate the first three non-zero terms in the expansion of psi n1, where psi n1 is the, as you know, the first order correctioning wave function. Remember that first order correction wave function is expressed as a sum as a linear combination of eigenstates, unperturbed states. So what are the first three terms, first three non-zero terms in the expansion? And thirdly, we want to calculate second order correction energy also. Okay, En2. Okay, so let us try to do it one by one. So first I will calculate En1. Okay, so what is the expression for En1? En1 is simply psi n0 v prime psi n0, right? So let us substitute the values. What is psi n0? Psi n0 is root 2 by L sine n pi by L into x, where n is equal to 1, 2, 3, etc. Right? So if you substitute that here, this is an integral. Okay. Now here, look at this. It's a real function. So whether it is in a bra vector or ket vector, there is no change, there is no complex conjugate. So if you substitute that, there is a root 2 by L sin n pi by L into x here, there is a root 2 by L sin n pi by L into x here. So root 2 by L comes twice, so I can take it outside. Root 2 by L into root 2 by L will be 2 by L. And the remaining thing is integral 0 to L. Since these are all real functions, I can write it in any point, and also there is no differential here, so I can combine this sine function here and sine function here. There will be a sine square term, and I can put this v prime also here. Alpha is a constant, so I can take it outside. So we have delta x minus L by 2, this is our v prime, and combining sine function here and sine function here, we have sine square n pi by L into x dx. Okay. Okay. That's equal to 2 by L into alpha. And you know the property of delta function. When delta function appears within an integral along with a function, okay, something like this, integral f of, delta x minus a f of x dx. Okay, this delta function is peaking at x equal to a. And not only this, important point is that this x equal to a, the point at which delta function peaks, it should come within the limit, the domain of integration. Okay, that means this integration should be from at least some epsilon term before a to some epsilon term, epsilon distance after a. Some epsilon distance before a to epsilon distance after a. So this integration should contain the point a. That is the meaning of this one. Okay. So here we are integrating from 0 to L. So definitely it contains the point x equal to L by 2 where this delta function peaks. Therefore this is valid. And what is the result of this one? When delta function appears within an integral along with a function, what you get is the value of the function at the point where the delta function peaks. Delta function evideയാണ് peak ചെയ്യുന്ന ആ പോയിന്റുള്ള ഫംഗ്ഷന്റെ വാല്യൂ ആണ് കിട്ടുക. അപ്പോൾ ഇവിടെ പീക്ക് ചെയ്യുന്നത് എവിടെയാണ്? അപ്പോൾ ഇന്റഗ്രേഷൻ ഓക്കെ ആണ്, ഈ ഡൊമൈനകത്ത് x equal to L by 2 വരുന്നുണ്ട്. അപ്പോൾ ഇത് പീക്ക് ചെയ്യുന്ന എവിടെയാണ്? x equal to L by 2 ആണ്. സോ വാട്ട് യു ഗെറ്റ് ഈസ് ദ ഫംഗ്ഷൻ, ഏതാണ് ഫംഗ്ഷൻ? സൈൻ സ്ക്വയർ n pi by L into x, sin you get f of x at x equal to a. അതായത് this function at x equal to L by 2. അപ്പോൾ x ന് പകരം ഞാൻ L by 2 സബ്സ്റ്റിറ്റ്യൂട്ട് ആണ്. ഇതാണ് റിസൾട്ട്. So L will cancel. What you get is 2 by L alpha sin square n pi by 2. This is the result. Now what is sin square n pi by 2? ഞാൻ ഈ ഭാഗം ഒഴിവാക്കാം. So en1 equals see, let us say n equal to 1. When n equal to 1, we have what is sine pi by 2. Let us look at the square later. Sine pi by 2 is 1. So sine square pi by 2 is also 1. What about n equal to 2? N equal to 2, we have 2 pi by 2. So we have pi. Sine pi is 0. So this term will be 0. N equal to 3, 3 pi by 2. Sine 3 pi by 2 is minus 1. But when you square it, you will again get plus 1. N equal to 4, 4 pi by 2 is 2 pi, sin 2 pi is 0. So what you get is, there are two sets of result. This is equal to for odd values of n. Okay, n equal to 1, 3, 5, 7, etc. This term will be either plus 1 or minus 1, but when you square it, sin n pi by 2 will be either plus 1 or minus 1, but when you square it, it will be plus 1. So result is 2 by L into alpha. For n is equal to 1, 3, 5, 7, etc. Odd values of n. And for even values of n, this term will be 0. So 0 for n is equal to 2, 4, 6, 8, etc. This is the result. The first order correction energy is to some constant 2 by L into alpha for odd values of n, 0 for even values of n. Let us try to understand why it is 0 for even values of n. Okay, mathematically we have seen that why it is 0. When you do this calculation, we have obtained it. But let us try to understand from the nature of the wave functions. If you plot the wave functions of this particle in a box, we have done this before. Okay. This is x equal to 0, x equal to L. This is the n equal to 1, psi 1, right? Okay. This is L by 2. N equal to 2 wave function is like this. This is psi 2. N equal to 3. Okay, this is n equal to 3, and n equal to 4. Okay, now you can see that for n equal to 1, okay, n equal to 1 and n equal to 3, similarly n equal to 5, for odd values of n, the wave function is symmetric about the x equal to L by 2, symmetric about the middle of the box. In other words, it's an even function. X goes to minus x, you will get about the point L by 2. When you take the value some distance, let us say some distance from L by 2, it will be the same as some distance from, so let us say I should not say minus x and plus x, but about the point L by 2, let us say L by 2 minus x, the value of the function at L by 2 minus x will be same as the value of the function at L by 2 plus x. So it is a symmetric or even about the middle. What about n equal to 2, n equal to 4, n equal to 6, etc.? These are odd functions. Okay, you can see that about the point L by 2 is anti-symmetric. Okay, it is inverting about the point L by 2. So it's an odd function. So about the point L by 2. So in the case of an odd function about the point L by 2, at the point of symmetry, its value will be 0. You can see that at x equal to L by 2, psi 2 is 0, psi 4 is 0, etc. For all even numbered wave functions, psi 2, psi 4, psi 6, etc., they are 0 at x equal to L by 2. See, our perturbation is applied at x equal to L by 2. Okay, so what happens for these even numbered wave functions is, even numbered wave functions, they don't experience the perturbation. കാരണം ഈ x equal to L by 2 ഈ ഈവൻ നമ്പേർഡ് വേവ് ഫംഗ്ഷൻസ് 0 ആണല്ലോ. അപ്പോൾ വേവ് ഫംഗ്ഷൻസ് അവിടെ 0 ആയതുകൊണ്ട് പെർട്ടർബേഷൻ്റെ ഇഫക്റ്റ് അവർക്ക് അനുഭവപ്പെടില്ല. അതുകൊണ്ടാണ് ഫസ്റ്റ് ഓർഡർ കറക്ഷൻ ഇൻ എനർജി ഈവൻ നമ്പേർഡ് വേവ് ഫംഗ്ഷൻസിന് എന്താവുന്നത് 0 ആണ്. ദേ ഡോണ്ട് സീ ദ പെർട്ടർബേഷൻ ബിക്കോസ് ദേ ആർ 0 അറ്റ് ദ മിഡ് പോയിന്റ് x equal to L by 2. Okay, now let us go to the first order correction in wave functions. Okay, the first order correction in wave functions are, okay, psi n1 is summation over summation over m, which is not equal to n, okay, this is first order correction in wave function. So yes, so we have to evaluate this, right? So let me evaluate this matrix element psi m0 v prime psi n0. It's an integral, right? There will be, these are unperturbed wave functions, so there will be a root 2 by L sine m pi by L into x here, root 2 by L sine n pi by L into x here. Let us calculate these first order correction in energy to the ground state. Okay, let us simplify this a bit. So I am calculating for n equal to 1 state, first order correction in n equal to 1 state. So here it is n equal to 1. So m not equal to n will be m not equal to 1. Instead of n, instead of taking the first order correction in nth state, I am simply taking the first order correction in first state. Okay, so here it is 1. It will be slightly simpler than the general case. So Okay, so we are calculating the first order correction for the ground state n equal to 1 state. For particle in a box problem, the ground state is n equal to 1 state. Okay, so this integral, so my point is that there will be sine m pi by l into x here, and there will be sine pi by l into x here. Okay, both will be having the normalization constant root 2 by l. So I will put 2 by l here. Okay, integral 0 to l, and then v prime is delta function alpha into delta x minus l by 2. Alpha we can take outside, delta x minus l by 2, and what is this psi m0 root 2 by l that has come here, sine, okay, ഇവിടെ എന്തായിരുന്നു വരുന്നത്, സൈൻ m pi by l into x. Okay, ഇവിടെ സൈൻ n pi by l into x, n equal to 1 നമ്മൾ ചൂസ് ചെയ്തല്ലോ. സോ സൈൻ n equal to 1, so സൈൻ pi by l into x dx. So that is equal to 2 by l into alpha. അപ്പോൾ ഇവിടുത്തെ നമ്മുടെ ഫംഗ്ഷൻ എന്ന് പറയുന്നത് ഇത് രണ്ടും കൂടി ചേർന്നതാണ്. ഇതാണ് നമ്മുടെ f of x. So integral delta x minus a f of x dx. The result will be f of x at x equal to a. ഇവിടെ നമ്മൾ a യുടെ സ്ഥാനത്ത് l by 2 ആണ്. So the result is this function at x equal to l by 2. What is this function at x equal to l by 2? Sin m pi by, ഇവിടെ നമുക്ക് സിംപ്ലിഫൈ ചെയ്തിട്ട് തന്നെ എഴുതാമല്ലോ അല്ലേ, sin m pi by l into l by 2. So l will cancel, so m pi by 2. Right? Here sin pi by l into x equal to l by 2. L will cancel, sin pi by 2. Right? Sin pi by 2. So this is the result. What is sin pi by 2? It is always 1. So our result is this. Right? Now this is, we know that this will be non-zero only for odd values of m. If m is even, then this will be 0, right? M is equal to 2, m is equal to 4, etc. This term will be 0. So for even values of m, this will be 0. This will be non-zero only for odd values of m. And for odd values of n, what are the non-zero values? This is either plus or minus 1, right? For example, m equal to 1, we get sin pi by 2, which is plus 1. M equal to 3, sin 3 pi by 2 is minus 1, like that. So it is plus or minus 1, so we have plus or minus 2 by l into alpha. Okay, അതാണ് നമുക്കിവിടെ കിട്ടുക. യെസ്, അപ്പോൾ നമുക്ക് പ്ലസ് ഓർ മൈനസ് 2 by l into ആൽഫ എന്ന് നമുക്ക് ഇവിടെ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യണ്ട. നമുക്ക് ഈ എമ്മിന്റെ വാല്യൂ കൂടി അറിഞ്ഞിരിക്കണം. എം ഏതാണെന്നുള്ളത് ഇവിടെ ചൂസ് ചെയ്യണമല്ലോ. സോ വി വിൽ സബ്സ്റ്റിറ്റ്യൂട്ട് ദിസ് വാല്യൂ ഹിയർ. സോ വാട്ട് യു ഗെറ്റ് ഈസ് psi 1 1 ഈസ്, ഈ മെട്രിക്സ് എലമെന്റ് നമ്മൾ ഇവാലുവേറ്റ് ചെയ്തതിൽ 2 by l into ആൽഫ കോൺസ്റ്റന്റ് ആണ്. സോ ഐ ക്യാൻ ടേക്ക് ഇറ്റ് ഔട്ട്സൈഡ്. സമ്മേഷൻ ഓവർ എം, m നോട്ട് ഈക്വൽ ടു 1, മാത്രമല്ല m ഓഡ് ആയിരിക്കും വേണം. അപ്പോൾ നമുക്ക് ഇങ്ങനെ പറയാം, m is equal to 1 കഴിഞ്ഞാൽ പിന്നെയുള്ള ഓഡ് വാല്യൂസ് 3, പിന്നെ 5, പിന്നെ 7, അങ്ങനെ പോകും. 3, 5, 7, 9, 11 അങ്ങനെ പോകും. ബാക്കി നമുക്ക് എന്താണ് കിട്ടുന്നത്? സൈൻ m pi by 2 ഓക്കെ, സൈൻ m pi by 2 ഇതിനകത്ത്. പിന്നെ ഈ psi m0 എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ വീണ്ടും ഒരു ടേം അവിടെ വരുമല്ലോ. എന്താണ് ടേം വരിക? റൂട്ട് 2 by l into sin m pi by 2 into m pi by 2 into x, right? So root 2 by l നമുക്ക് ഇവിടെ പുറത്തെഴുതാം. So root 2 by l sin m pi by 2 into x. ഈ ടേം, ഓക്കെ, റൂട്ട് 2 by l sin m pi by 2 into x. psi m0 ആണല്ലോ. ഓക്കെ, സോ ദിസ് ഈസ് ദ സീരീസ്. ഇനിയിപ്പോൾ നമുക്ക് ഇതിനകത്ത് ഫസ്റ്റ് ത്രീ നോൺ സീറോ ടേംസ് ഏതാണെന്നാണ് അറിയേണ്ടത്. സോ ദിസ് ഇസ് ഈക്വൽ ടു അടിയിലത്തെ ടേം കൂടി എഴുതണം. സോ E10 മൈനസ് EM0, റൈറ്റ്? ഇതും കൂടി ഇല്ല. ഓക്കെ, ഇവിടെ EM0 എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ പാർട്ടിക്കിളിനെ ബോക്സിന്റെ അൺപെർട്ടർബ്ഡ് സ്റ്റേറ്റിന്റെ എനർജി അയക്കുന്ന വാല്യൂസ്. mth സ്റ്റേറ്റിന്റെ ആകുമ്പോൾ ഞാൻ എമ്മിന് ടേംസ് പറഞ്ഞു കഴിഞ്ഞാൽ, ഓക്കെ, ഇവിടെ വേണമെങ്കിൽ നമുക്ക് ചെയ്യാവുന്ന ഒരു കാര്യം, ഇവിടെ ഒരു പ്രോബ്ലം വരും. എന്താണെന്ന് വെച്ചാൽ നമുക്ക് എനർജിയുടെ എക്സ്പ്രഷനകത്ത് മാസ് ഓഫ് ദ പാർട്ടിക്കിൾ വരും. മാസ് എം ഉള്ളൊരു പാർട്ടിക്കിളാണ്. അപ്പോൾ നമ്മൾ ക്വാണ്ടം നമ്പർ എം കൊടുക്കുന്നു, മാസ് എം കൊടുക്കുമ്പോൾ കൺഫ്യൂഷൻ വരാം. അപ്പോൾ ഇവിടെ നമ്മളിപ്പോൾ n=1 നമ്മൾ ചൂസ് ചെയ്ത് കഴിഞ്ഞു. അപ്പോൾ ഇനി നമുക്കിവിടെ ഈ ഡമ്മി വേരിയബിൾ എമ്മിന് പകരം എനിക്ക് n ഉപയോഗിക്കാം. എമ്മിന് പകരം നമുക്ക് എന്ത് ഉപയോഗിക്കാമല്ലോ, സമ്മേഷൻ ഓവർ എൽന്നോ അങ്ങനെ എന്തെങ്കിലും ഉപയോഗിക്കാം. ഞാനിവിടെ n ചൂസ് ചെയ്യാം. ഇവിടെ n വരും, ഇവിടെയും n വരും. Here also. ക്വാണ്ടം നമ്പർ ഞാൻ n ആയിട്ട് എടുക്കാം, മാസ് m, രണ്ടും കൂടി കൺഫ്യൂഷൻ വരണ്ട. സോ En0 എനർജിയുടെ nth സ്റ്റേറ്റിന്റെ വാല്യൂസ് n² π² h² ഡിവൈഡഡ് ബൈ 2ml². ഇതിൽ n=1 ആണെങ്കിൽ എന്താ കിട്ടുക? En0 π² h² by 2ml² വരും. So that is equal to, I can write nth state as n² times E10 എന്ന് വിളിക്കാം. അപ്പോൾ അത് ഞാനിവിടെ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്ത് കഴിഞ്ഞാൽ E10 എനിക്ക് രണ്ട് ടേമും പുറത്തെടുക്കാം. സോ 1 മൈനസ് n² ഇൻറ്റു E10 എന്ന് വരും. അപ്പോൾ E10 ഡിനോമിനേറ്റർ ഞാൻ പുറത്ത് എടുത്തു കഴിഞ്ഞാൽ 1/E10 വരും. സോ psi11 okay is equal to 2/L into alpha root 2/L. E10 ഡിനോമിനേറ്ററിലാണ് വരിക. ഓക്കെ, അപ്പോൾ ഇതിൻ്റെ റെസിപ്രോക്കൽ വരും. സോ വി ഹാവ് 2ml² ഡിവൈഡഡ് ബൈ π² h². ഇതല്ലേ E10, 1/E10. അത് പുറത്ത് വരും. ബാക്കിയുള്ളത് സമ്മേഷൻ ഓവർ n is equal to 3, 5, 7 etc. sin n π/2 into sin n π/2 into x divided by, ഇവിടെ ഇനി ബാക്കിയുള്ള എന്താണുള്ളത്? 1 മൈനസ് n². ഇങ്ങനെയുണ്ടാവും. ഓക്കെ, ഓക്കെ, so that is equal to 2/L alpha root 2/L 2ml² by π² h². ഓക്കെ, നമുക്ക് ഇതിനകത്ത് ഫസ്റ്റ് 3 ടേംസ് ഏതൊക്കെയാണെന്ന് നോക്കാം. n=3 കൊടുക്കാം. n=3 കൊടുക്കുമ്പോൾ sin 3π/2 വരും. sin 3π/2 എന്ന് പറഞ്ഞാൽ -1 ആണ്. പിന്നെ ഇവിടെ ഒരു 1 മൈനസ് 9 വരും. സോ -1 ഡിവൈഡഡ് ബൈ 1 മൈനസ് 9 ഇൻറ്റു sin 3π/2 ഇൻറ്റു x. ഓക്കെ, n=3 കൊടുക്കുമ്പോൾ അടുത്ത n=5 കൊടുക്കാം. sin 5π/2 എന്ന് പറഞ്ഞാൽ 2π പ്ലസ് π/2 ആണ്. അതായത് sin π/2 തന്നെയാണ്. sin π/2 എന്ന് പറഞ്ഞാൽ 1 ആണ്, +1 ആണ്. അടിയിൽ എന്ത് വരും? 1 മൈനസ് 5² അല്ലേ, 25 sin 5π/2 ഇൻറ്റു x പ്ലസ് അടുത്തത് n=7 sin 7π/2 എന്ന് പറഞ്ഞാൽ 2π പ്ലസ് 3π/2 ആണ്. അതായത് sin 3π/2 ആണ്, which is -1. That is -1 divided by 1 minus 7² 49 sin 7 pi by 2 into x plus etc. So these are the first three non-zero terms. Let us further simplify them. Okay, so psi 1 1 is equal to 2 by L into alpha root 2 by L 2ml square by pi square h cross square. Okay, then we term minus 1 by 8, sorry, plus 1 by 8. This is minus 8, minus of minus plus, so plus 1 by 8 sine 3 pi by 2 into x, and minus 1 by 24 sine 5 pi by 2 into x. This will be, the denominator will be minus, numerator is minus, so plus 1 by 48, 1 minus 49 sine 7 pi by 2 into x. The next term will be minus, okay, so minus etc. Now you can take 1 by 8, 1 by 24, 1 by 48. So 8 is common, you can take 1 by 8 outside. So we have psi 1 1 is equal to 2 by L. So okay, let us simplify all these terms. So I can take a 1 by 8 outside. So we have 2 into 2 4, 4 and 1 by 8 we can cancel. So there will be a 1 by 2 in the denominator. So this root 2 and 1 by 2 you can cancel. So there will be a 1 by root 2. So root 2 in the denominator. And 1 L and L square will cancel. You have an L. This root L and L will cancel. So you have a root L in the numerator. So we have root L by 2. Okay. So this 2L are gone. And the remaining terms are alpha into m divided by pi square h cross square. Alpha into m by pi square h cross square. And inside we have sine 3 pi by I think this is L, not 2. It should be sine m pi by L into x. I think I wrote sine m pi by 2 into x. It should be sine m pi by L into x. Okay, so it's on sine 3 pi by L into x. Only in the first term the L is cancelled. Okay, so here it is, when you take 8 outside, 1 by 3 sine 5 pi by L into x. Then next is plus, if you take 8 outside, 1 by 6 sine 7 pi by L into x minus etc. So this is the result of first order correction in wave functions. Okay, root L by 2, alpha m by pi square h cross square, and these are the first three non-zero terms. Now we can go to the third part. Second order correction in energy. Okay, part C. This second order correction in energy. This time we will calculate for the nth state. Okay. Second order correction in energy is summation over m not equal to n. This is a square. Okay, this is second order correction energy. Okay, so as before, we need to calculate this matrix element. So psi m0 v prime psi n0, instead of h prime let me use v prime. So this we have done before. So what you get is there is a root 2 by L and there is a root 2 by L from here. So I am not taking n equal to 1 this time, I am taking a general state, nth state. So okay, the integral is from 0 to L, and the perturbation you have a constant alpha outside, delta x minus L by 2 sine m pi by L into x into sine n pi by L into x dx, right? Now that's equal to 2 by L into alpha. Okay, so the function is this one, the product of this one. So the result is the value of this function at x equal to L by 2. So when you put that sine, put x equal to L by 2 in the first term, so L will cancel, we have m pi by 2 into sine, next term will be n pi by 2. This is the result of this matrix element. Now you know that this will be non-zero only if both m and n are odd. If either m or n is even, the result will be 0. So both m and n should be odd. Now when both m and n are odd, this product is either plus 1, m is different from n. Okay, so this product is either plus 1 or minus 1, right? Either plus or minus 1. So we have this is plus or minus 2 by L into alpha. But we will be squaring this matrix element, so you will get essentially the square of this 2. Okay, so let us substitute that. So let us substitute this value. So we have second order correction in energy is the square of this 2. Okay, so this square we can take out. So 4 by L square into alpha square, right? Summation over n not equal to n. Both En0 and Em0 I can express in terms of E10. Okay, so this En0 will be n square times E10, Em0 will be m square times E10. So I can take this 1 by E10 outside. So essentially we have n square minus m square. Okay, this is what we will get. M is not equal to n. Okay, so now we want to evaluate this sum. So in order to evaluate this sum, so summation over m not equal to n, 1 by n square minus m square. Okay, we can use a technique. I will write this sum, this term as the difference between two different summations. Like this, I can write this as summation over m not equal to n. I can write this term as 1 by 2n into, right, 1 by m plus n minus 1 by m minus n. Okay, let us check it. If you take the LCM, you have m minus n minus m plus n. So you will get minus 2n in the denominator divided by m plus n into m minus 1n, which is m square minus n square. So this 2n and 2n will cancel. Minus sign, you can change the variable. You have in the denominator, you will have m square minus n square. If you change the variable, you will get n square minus m square. Okay, so this term, okay, this 1 by 2n into 1 by m plus n minus 1 by m minus n. This is exactly same as this one. So essentially we are writing this term as the difference between two series. Okay. Okay, now let us evaluate this. I am taking each value of n, right? And finally I will generalize. So first let me take a particular value of n. let's start with n equal to 1. Then I will take, remember that n and m should be both odd. So I will first take n equal to 1. Then you can choose different values of m. Then I will take n equal to 3. Then we can have different values of m, and like that we can try to do a few examples, few specific cases, and then I will generalize. Okay. Yes. So let us use here. Okay. Maybe I will use here for. First, let us take n equal to 1. Okay. For n equal to 1, this summation, that is left hand side summation m not equal to n, 1 by n square minus m square. This is equal to, you are putting n equal to 1. So 1 by 2 into, let us put the different values of m. So essentially what you get is 1 by 2 into 1 by m plus 1 minus 1 by m minus 1, right? I am choosing n equal to 1. Okay. Summation over m is equal to, so what are the different values of m? N is equal to 1. So m should not be equal to n, and another point is that m should be odd. Okay. So what are the values? 3, 5, 7, etc. Just as in our part B of our calculation, we have chosen n equal to 1 specifically. So at that time m was 3, 5, 7, etc. Okay, so let us see what are these values. So that is equal to, left hand side is equal to half into, okay, right hand side becomes, put m equal, so first I will put the different values of m in the first term and then the second term. So what is the first term? M is equal to 1. Okay, so what you get? Not m is equal to not 1, m is equal to 3. Okay, so we have 3 plus 1, 4, plus m is equal to 5. So 5 plus 1, 6, plus 1 by 7 plus 1, 8, plus etc. This is 1 by m plus 1. Summation over m, 1 by m plus 1. Now minus summation over m, 1 by m minus 1. Okay, put m equal to 3. So 3 minus 1 is 2, minus, next is 5. 5 minus 1 is 4, minus 7 minus 1 is 6, minus etc. So this is a series, this is a series. But you see that there is a 1 by 4 here, there is a minus 1 by 4 here. 1 by 6 here, minus 1 by 6 here. Next term will be 9. So 9 minus 1 will be 8. So there will be a minus 1 by 8 here, there is a plus 1 by 8. So these terms will cancel except for this term. Okay, so what you get is 1 by 2 into minus 1 by 2, which is equal to minus 1 by 4. For n equal to 1. For our choice n equal to 1. So we have evaluated this summation for n equal to 1, we get this. Let us repeat this procedure for n equal to 2. Okay. So let us say for n is equal to 2. No, n is equal to 2 is not possible. Both n and m should be odd, so n is equal to 3. So summation over n not equal to n, and so number m should be odd. 1 by n square minus m square, this is equal to, what you get is summation over, okay, we know that m should be, okay, we will see what are the different values of m. Okay, when n is equal to 3, we have here this is that formula, so put n equal to 3, so 1 by 6, 1 by m plus 3 minus m minus 3. Okay, we have chosen n equal to 3. If n is equal to 3, what are the different values of m? What are the different odd values of m? M is 1, next is 3, but 3 is not allowed because m is not equal to n. So then 5, 7, etc. Okay, let's put different values. So this is equal to, left hand hand side is equal to 1, right hand side becomes 1 by 6. What about the first series? Put m equal to 1. So 1 by 4 plus 1 plus 3, 4. The next is 5. So 5 plus 3 is 8. Plus next is 7. 7 plus 3 is 10. Plus etc. Minus. Okay. The first term is 1. So 1 minus 3. 1 minus 3 is minus 2. Minus 2 and minus will be plus. So we have plus 1 by 2. Minus. Next is 5. 5 minus 3 is 2. So we have minus 1 by 2. Next is 7. 7 minus 3 is 4. Okay. Let us write a few more terms. Next will be 9. 9 minus 3 is 6. Next will be 11. 11 minus 3 is 8. Minus etc. You can see 1 by 4 is cancelled. 1 by 8 is cancelled. 1 by 2 is cancelled. You will have 1 by 10 also. For example, when you put 11, you have 11 minus 3, 1 by 8 has come. Next is 13. 13 minus 3 will be 10. So after minus 1 by 8, you have minus 1 by 10. Okay. So this 10 cancels, 8 cancels, 4 cancels, 1 by 4 cancels. This plus half and minus half cancel. So what is the remaining term? Only remaining term will be minus 1 by 6. You have a plus 1 by 6 here. So plus 1 by 6 into minus 1 by 6. You have minus 1 by 36. This is for n is equal to 3. Okay. So in this way we can proceed. We can proceed for different values of n. And the result will be, okay, the result will be always, there is an extra term 1, there is a term 1 by 2n first, right? See, what was this summation? We have rewritten this as 1 by 2n summation over m not equal to n or 1 by 2n into 1 by m plus n minus 1 by m minus n, right? Always what we get is this 1 by 2n into, okay, a similar term will remain inside. You will have a minus 1 by 2n. How you get is, get this is, this m equal to n is not allowed, remember? Okay, so there will be a 1 by 2n here, this term here, but that term will not be cancelled here. Okay, this minus sign will come automatically in that process. So always the result will be 1 by 2n into minus 1 by 2n. Okay, that is minus 1 by 4n square. This will be the result always. Okay, so we can put that here. So the final expression for En2 will be, I will substitute that minus 1 by 4n square. So there is a minus sign, 4 by L square alpha square. And what is this term? E1 0 was pi square h cross square by 2ml square. So 1 by E1 0, 2ml square by pi square h cross square. And this is minus 1 by 4n square. I have put a minus here. So 1 by 4n square. Okay. So that is equal to 4 will cancel, L square will cancel. So 2m into alpha by pi h cross n whole square. Correct? 4 will cancel, L square will cancel. 2m into these are all perfect squares. Alpha square, pi square, h cross square, n square. So alpha by pi h cross n whole square with a minus sign. Okay. So for the nth state, this is the second order correction in energy. From this you can calculate the second order correction for each state. Put n equal to 1, you will get the second order correction for the first state like that. So what we have done is, we have taken this infinite square potential well. We have applied a perturbation, a delta function perturbation at the middle of the box. And we have calculated the first order correction in energy. We have seen that this first order correction in energy will be non-zero only for odd values of n. It will be 0 for even values of n. And we know the reason, because for even values of n, wave function is 0 at the midpoint, so it cannot experience the perturbation. Then we calculated the first order correction in wave functions, at least for the ground state. For the n equal to 1 state, we calculated the first order correction in wave functions, and again for the nth state we calculated first order correction in energy values.